All right, let's get right into it. We're going to talk about something absolutely crucial, one of the most vital stats your body keeps track of, cardiac output. You can think of it like the master performance metric for your heart, the engine of your body. It tells us, in real time, just how hard that engine is working. You know that feeling, right? Your heart just pounding in your chest before you have to give a big presentation? Or how about that steady, powerful beat when you're in the middle of a good run? They feel so different, don't they? But they're actually both driven by the exact same system, a system that's constantly trying to answer one single question. How much blood does the body need right this very second? Well, the answer to that question, and really the key to understanding your heart's amazing ability to adapt, it all comes down to a single critical number. So let's break down this master metric. And that number is cardiac output, or CO for short. So what is it? Put simply, it's the total amount of blood your heart pushes out every single minute. It's kind of like the ultimate performance report card for your heart, telling you exactly how well it's doing its main job, supplying your body with all the fuel, all the oxygen and nutrients that it needs to, well, function. And you know, the way the body figures this out is with a surprisingly simple formula. It's just your heart rate multiplied by your stroke volume. That's it. It's literally just how fast your heart is beating times how much blood it's pushing out with every single one of those beats. Speed times strength. That's the whole equation.
So what does that actually look like in the real world? Well, for an average adult who's just, sitting around and resting, your heart is pumping about 5.25 liters of blood every single minute. To put that into perspective, that's more than 2 of those giant soda bottles circulated through your entire body every 60 seconds. It's just an incredible amount of work, and it's all happening completely silently, in the background, without you even thinking about it.
Okay, so if the body needs to change its cardiac output, say when you stand up and start walking, how does it actually do it? Well, it has these 2 main control dials it can play with. There's the speed dial, which is your heart rate, and the strength dial, your stroke volume. Let's take a look at how it fine-tunes both of them.
All right, let's start with the speed dial, your heart rate. Your body basically has a built-in gas pedal and a brake. The gas pedal, or the accelerator, is your fight or flight system. It floods your heart with adrenaline-like signals to really speed things up. And the brake, that's your rest and digest system. It uses a totally different chemical signal to gently slow everything back down. So your heart rate at any given moment is really just this delicate dance, a constant balancing act between these 2 opposing forces.
Okay, so what about the strength dial, our stroke volume? Well, this one's a little more complex. It's governed by 3 key things. First up is preload. The best way to think about this is like filling up a water balloon. The more blood that fills the ventricle, the more the heart muscle stretches. Simple, right? Then you've got contractility. This is just the raw, brute force squeezing power of the heart muscle itself. And finally, there's afterload. This is all about the resistance the heart has to push against to get that blood out. It's kind of like trying to squeeze water through a really narrow hose. All 3 of these together determine exactly how much blood gets pumped out with each and every beat. So let's put it all together. Imagine you suddenly break into a run. What does your body do to ramp up that cardiac output? Well, it basically turns all the dials up to 11. It slams on the accelerator to jack up your heart rate. It squeezes your veins to push more blood back to the heart, which increases that preload. It floods your system with hormones to make the heart muscle contract way harder. That's boosting contractility. And to top it all off, it makes the job easier by relaxing your arteries, which lowers the afterload. It's this perfectly coordinated, all-at-once surge of power. And what about when it's time to cool down? You finish your run. Well, the body just does everything in reverse. It gently applies the brake to slow down your heart rate. It sends out signals that tell the heart muscle to ease off, reducing the force of each contraction. It pretty much just dials everything back down from a full-on sprint to a nice, leisurely stroll. It's this really elegant system of push and pull. You know, this brings up one of the heart's most amazing built-in features. It's called the Frank-Starling mechanism, and it works just like a rubber band. The more you stretch it, the more powerfully it snaps back. It's the same with the heart. The more blood that fills it up, which increases that stretch, that preload we talked about, the more forcefully it's going to contract. It's this incredible, self-regulating trick that's just built right into the muscle fibers themselves, no brain required. So this all begs a pretty big question, right? How does the body actually know when to turn these dials up or down? I mean, it's not just random. The whole thing is managed by this incredibly smart, multi-layered control center that's getting constant feedback 24/7. Okay, so the first line of defense, the body's rapid response team, if you will, are these amazing little sensors called baroreceptors. The best way to picture them is as tiny pressure gauges that are strategically placed in your major arteries, and their only job is to constantly monitor your blood pressure. So here's how that works in a real-life situation. Let's say you stand up way too fast, and for a second, your blood pressure plummets. Instantly, and I mean instantly, those little pressure gauges detect the drop. A signal zips to your brain's control center, which immediately slams on the accelerator. It tells your heart to beat faster and harder, and at the same time, it tells your blood vessels to tighten up. And just like that, your blood pressure is right back to normal, often before you even have a chance to feel dizzy. But what about situations that need more than just a split-second fix? For that, the body calls in the long-term management team, and that's your endocrine system, which uses a whole host of hormones to regulate your blood pressure and blood volume over hours or even days.
Now, this hormonal system basically has two main game plans. If your blood pressure is consistently too low, your kidneys jump into action. They release hormones that do two key things. One, they tighten up your blood vessels, and two, they tell your body to hang on to more water, which increases the total amount of blood in the system. But what if your pressure gets too high? Well, then your own heart cells release a different hormone that does the complete opposite. It tells the kidneys, hey, we need to get rid of some of this fluid, so they flush out excess salt and water, bringing both the blood volume and the pressure right back down into a healthy range.
So when you put it all together, what you're really seeing is a system that is never, ever static. It's just this constant, beautiful, dynamic balancing act. And it's happening every single second of every single day of your life.
And really, that's the main takeaway here. That sense of balance in your body, what scientists call homeostasis, it isn't some fixed state you arrive at. No, it's an active, non-stop process. All of these pieces we've just talked about, the nerves, the hormones, the heart muscle itself, they're all in constant communication with each other, making millions of tiny little adjustments to perfectly match your heart's output to what your body needs at that very moment, whether you're fast asleep or in a full-out sprint. So, to wrap this all up, just think about this for a second. This silent, unbelievably complex, and completely self-regulating system is adjusting your cardiac output perfectly, millions upon millions of times throughout your life, and you never have to give it a single conscious thought. So what does that incredible feat of biological engineering really tell us about the sheer resilience and the absolute brilliance of the human body?